Can anyone, other than the people that should know, can anyone tell me what I've got a picture of up here? Which computer? Yes, the very first computer. All right? Now, the computer is very important for what we're going to talk about because the computer is a metaphor of what's wrong. We have grown up in an age where the things that the computer do has helped define what we believe to be success. And computers can indeed do many things, and they do many things well. But no matter how big the computer is, no matter how skilled the computer is, no matter how much we make progress with Moore's law, computers, as they're presently designed, do one thing at a time. We can make the thing much smaller, we can make it much faster, we can try to run them in parallel, but they still only do one thing at a time. Well, that's interesting, but we're humans, and humans behave differently. So when we go to look at what it is that defines that one thing, for humans, that's a very difficult question. We don't just do one thing at a time. Our sensors take in many things at a time, many, many things. And trying to narrow our full attention to one thing at a time is actually beyond our capabilities. So if we were to try an example, the normal example, if I had more time that I do with a crowd, is to say, please draw a picture of the Earth. And with that simple example, you'd be surprised how many pictures emerge in the crowd. And we could go on with other examples like that, but we're running late and we don't really have time for it. So the lesson is that computers, unlike people, learn code. They focus on one-to-one mappings. Now, if you get a complicated thing, you can make the mappings context-dependent, but nonetheless, the way computers function is with a lookup table, which is the definition of a code. I see a sign, I go to the lookup table, I can see what it's supposed to mean. The computer does not understand meaning. The computer is not a person. And when we define our notions of success and what works, in a world where the computer has been doing the definition, we run into problems. So humans can memorize code. We're all fairly good at that if we need to. It's very efficient. It's a shortcut. Codes are not meaning. Notice that we were told about the green book and the gray book. That had meaning instantly. It wasn't inherent in the color green or gray. The meaning was attributed to it by the people who gave it meaning and then by the observers who understood that meaning from the observation and the context that was summoned up. The poor computer being told, look for the green book, will find a book that's green, but it'll have no idea why that has any significance whatsoever. Meaning starts with context. And I'm sure you've all seen, you know, the lovely elephant and everybody looking at their own pieces of it. When you do things one at a time, your ability to capture the whole is very difficult. But people can do this. This is just part of who we are. So again, this notion of a success in the modern world driven by computer definitions raises issues. Learning in life is different from the way we define learning in science. And most of modern science has taken its definitions from the computer age. So there are different goals, there are different experiences. And if we base what we do on the definitions of formal education, on science, on the computer, we're going to run into problems. So let's take life. So in life, the first thing that happens is there's a sense of general fuzziness. And then we try to abstract some patterns, familial patterns I'm going to call them. There's sort of families of things. And then we identify some archetypes with regard to those patterns. And then finally, we attribute contextual triggers to the archetypes, and voila, we now have meaning. Well, science and the scientific method and the computer change the order of these things. So in science, we still have fuzziness, because guess what? We start with a fuzzy world. But the next three get flipped on their head. So what happens? First, we observe data in context. And from our observations of data in context, and we tend to forget about the context, we map that to archetypes. And then once we have the archetypes, we now start ascribing rules to these lovely familial patterns. And these become the laws and the rules. Well, these three steps are exactly reversed between the scientific method and life. But most of us seem to have missed this lesson someplace along the way. So conflict happens at the archetypal stage. You may see an archetype that is different from what I see. And how did this happen? Well, we're different people. We had different experiences. We had a different history. Life was different for us. So when we observe the patterns, the archetypes that we drew might be very different. And if we each assert that there's something that we're supposed to be seeing in common, but we see a different archetype, we might have a conflict. And another name for that conflict is ambiguity. The same archetype is summoning up two different meanings. People in life need to deal with ambiguity. The computer might find some ways of getting rid of it, bracketing it off, reassigning it to some kind of weird probability function. We don't have that luxury. We actually have to deal with it. So the usual quote that I like to flip around on its head is the one that says that the unexamined life isn't worth living. And my reply is, and the unlived life is not worth examining. And we need to do both. So why is it that we live in a modern world where we don't like ambiguity? We think we're supposed to get rid of it. Well, the first reason is that lovely computer again. Computers are very good at dealing with data. Data is not well processed when it's ambiguous. You substitute things, you bracket them off, you assign probability functions, but you do anything you can to get rid of the ambiguity. And it's been very successful. We live in a very nice modern world. When I first came to China in 1977, I can assure you, this city and everything I saw looked extremely different. People's lives were extremely different. And much of the change that has gone on in those 40 years has been because of taking a modern approach where data and one-to-one meanings were important. But there's more to life than just that. Now, the second reason is causality. And what happens is the modern approach is that linear causality is everything. If you can directly say that A causes B, that's what you're after. And there's large portions of the world where indeed simple direct causality works. But guess what? There's large portions of the world where it absolutely does not work. Where causality is either many-factored and you can't point to any one thing, or it might be circular, or it might be completely contextually dependent. It might not be repeatable. That's all messy. That's all ambiguous. And when we go to teach things via the scientific method and a reliance on science and the modern project, we get rid of it. But it's a large portion of the world. Finally, is the thing that I said before. The modern project has been a great success. We're sitting in a much more advanced world. We have lovely things like this computer, like this microphone, like this pointer, all of which were made possible because we relied on one-to-one mappings, codes, getting rid of ambiguity, direct causality. There's a large portion of the world in which this method works really well. But That's not the main portion of the world. It's this nice simple portion down here where things are close to certainty, where things are close to agreement, and the world has other parts to it. As you go off into this corner, things get more complicated, they get more complex, they get chaotic. Things are far from agreement or far from certain. And all of those nice things that the computer can do really well, it does really well in this corner. And when you get up here, it doesn't do them so well. You get two choices. You could say, I'm not going to deal with that. That is certainly a choice, and it's a choice that works for many things. But again, we're people. And most of our lives are actually up in this portion of the world. So ambiguity is the first cue that you are not in the simple portion of the world. If things seem to be ambiguous, that's a good clue that something else is going on. And then the question becomes, how do you deal with it? Are you going to deal with it? So the first question is, are you going to deal with it? And then, how are you going to deal with it? So if you see something, and this may mean more to the western part of the audience than to the eastern part of the audience, but this is a famous book from years ago that suggested that men and women are different, and that men are from Mars and women are from Venus, and that they have different brains, they think differently, and that explains much of what goes on between us. So how do we deal with ambiguity? And we deal by coping. We don't deal by mastering. We don't deal by conquering. We deal by coping. I've got a quote up here from Richard Rorty. And Richard Rorty says, knowledge is not a matter of getting reality right, but rather a matter of acquiring habits of action for coping with reality. And that's what we do. Don, over the past few days, liked to keep citing Mr. Lindblom, who talked about muddling through, but the reality is we cope. And coping and muddling are sort of related concepts. So how do we do this? I come from cybernetics. So one of our observations is that we create our own reality. We see the world. We tell stories in our heads. And then we tell other people about the meaning we derived from those stories. We are not dealing with a world that is out there, with a fixed world that has some defined existence. We are dealing with the world that's in people's heads. And what's in my head and what's in Ken's head and what's in Don's head may be very different. And we have to deal with that. So what do? Well, we filter. So the first thing that we do is we limit our field of attention. Can't take in everything. You've got to narrow your context. The next thing that we do is we limit the factors to be considered. So now we bring in boundaries and constraints. And we just keep narrowing down. Then the next thing that we do is we say, well, what are the likely outcomes? And we engage in some kind of prediction. And then finally, we choose among those predictions. And this gives us the story that we both tell ourselves and that we tell other people. It leads to a quest for certainty that maybe cannot be satisfied. We want clarity. We want certainty. What we often get instead is it's one or the other, but it isn't clear which. Clarity is available in the simple portion of the world. If you can map things one-to-one, you can be clear. But clarity is elusive in the more complex part of the world. When things have one-to-many and many-to-one mappings, clarity is very elusive. It's hard to get. You can't find it necessarily. Simple models, simple labels are inadequate to capture nuance. They're inadequate to capture the ambiguity. So if you choose to use a simple model or a label to express the representation of a situation, you are choosing to throw nuance and ambiguity away. And you need to be aware you are making that choice. You're bundling the ambiguity up, You're treating it like it's a black box, and you're hoping it has no outcomes because you are hiding it. And we have a basic assumption that more is often better, and I actually was in Berlin a couple of months ago and found this horrible device. This is an instance of more not being better. And by the way, the only reason I don't have it with me is there's no way to get that through customs and airport security. But they do sell it. So when everyone is in agreement, when you start off with a context where people are on the same page, more indeed is better. And the two lines of my graph here are that there's acceptability, which is the willingness to engage in a meaningful dialogue, and the other is similarity, that the positions are similar. And when people are on the same page, you get this nice 45-degree line. They talk about it in communication theory a lot. But the assumption is that people are actually seeing the same thing. It's an assumption. And what about when they don't see the same thing? What about when it's ambiguous and there's conflict? Then what? And they did teach you this in school. They taught you this a long time ago in school, but you tended not to learn it. So we all learned about the standard deviation and a nice distribution. And let's assume that that curve is the universe. Well, that's fine. But that doesn't mean that we know that. So it may be that when I look at the data, I see that curve. And it may be that when you look at the data, you see this curve. Well, you can run lots of models. And the models will tell you that if these things are roughly a half a standard deviation apart, they are likely to converge. And you'll come back to that nice black line. And when they're more than half a standard deviation apart, you aren't going to get convergence. You're going to get ambiguity and conflict. And we're not God. We're not omniscient. Most of us have no idea when we look at data that we actually are seeing the correct black line. We might be seeing the blue one. We might be seeing the red one. We might be seeing some other green or purple one. And if I see one that's different than you, only if we actually started off in a place that's close are we going to converge. So let's take an obvious example where this comes up all the time, the notion of climate change. I'm going to show you the same graph twice. So this is the way you're probably used to seeing the graph. Nice, increasing slope, the world is warming. Simple story. Everyone gets it. What is there to be argued with? Well, let me give you another way of looking at exactly the same data, exactly the same graph. The upward slope for the average is still there, but it turns out that there's these nice periods where there's some fairly level lines. It's the same data. You cannot argue that that graph is unambiguous. It's how you choose to look at it. So again, when everyone agrees, more is better and we're fine. But we have to deal in a world where that isn't always the case. So when there are multiple meanings, there is what I call the chasm of dissonance. And what happens, and this is a very important curve, and you may have seen this curve in a different setting. So this is exactly the same curve as the Moore-I uncanny valley. So if you're familiar with that at all, this is the same curve. It's just now been broadened in definition. So in the beginning, as you go up, and we're getting more and more information, that old 45-degree line holds. But at a certain point, something very strange happens. And if there's more than one meaning, more than one interpretations of the archetypes, and there's conflict, we have a bunch of dissonance here that we have to overcome. So if I go backwards, the people who see this and the people who see this are in that chasm of dissonance. They're talking about the same graph. They are drawing very different conclusions from that graph. And the more you talk at them or amongst them, you're not helping matters any. all that happens is that they're sunk in this bottom of this chasm. If you want to narrow it and you want to make things very specific, you can get agreement again. If you want to become more ambiguous and become more abstract, you can get agreement again. But at the level of those archetypes, we've got some severe disagreements going on. And it's a very important curve that most people just aren't necessarily aware of. So my lesson for you is that dealing with ambiguity, getting between the specific and the abstract, in whichever direction you feel like going, is like building a bridge. You've got to overcome that chasm. There are many ways to overcome the chasm. You could start with some islands of stability, which is the context-specific stuff, and then build little bridges amongst all the islands of stability till you get across. You could begin with an abstract idea and keep talking about the abstract and build your bridge that way. Or you could do what they learned to do with suspension bridges, and you could find some things that are orthogonal, something related but that moves in a perpendicular direction, and that actually allows you to build a much longer, bigger bridge. So it's the upright things here that allow the bridge to have that stable plane. So what you want to do is you want to take into account some choices. Choice one, greater abstraction allows more room for ambiguity. That's an option. Choice two, you could add constraints to narrow focus, because if you make the context actually clear, it's hard to argue with. Choice three, you could just do nothing. Get stuck in arguments like climate change or in the US abortion and gun control. Or you can build a bridge. So my lesson for you is you want to be engaged in bridge building. If you believe that that bridge can just be a rope bridge, you're going to be in for some severe disappointment. But everything that's a bridge starts with a rope bridge. You've got to remember that merely tossing the rope over is only a beginning. You've got to then take some actions in order to fix it. You've got to make it more stable. You've got to do something with it. You can't go between the context-specific and the abstract by merely saying, I've got a label. I've got a model. That's a rope bridge. You've got to back it up. You've got to give people a reason to believe. You've got to give it depth. And if you don't, well, you could end up drowning. And that's not where you want to end up. But I've got to remind you, it all starts